In the last lesson, we saw how to use the law of sines to solve for missing sides or angles on a triangle. So here's a triangle where I'm trying to find CB. I'm just going to call that X. So I'll try and do the law of sines. X is across from 44, so X over the sine of 44 should equal 13 over, I don't know that angle, so we'll just say sine of angle C, or it should equal 6 over the sine of, I don't know, angle B either. So here's where I run into my first problem with law of sines. It works for all triangles, but if I don't have the right information on the triangle, it's not going to give me a proportion that I can solve. So it is what I would always look for first, but in this case I don't have enough information to do that, so I've got to come up with a new plan. So let's go back like in lesson 3 where we created right triangles that we could work with. So by drawing an altitude in this triangle, I have now built a right triangle on the left and a right triangle on the right that I can work with. And I'm going to go ahead and transfer the numbers that I have onto these triangles. In the triangle on the left, I have a 44-degree angle, I have a hypotenuse of 6, and I have the 90 degrees from the altitude. On the other triangle, I have side X that I want to know. I have the 90 degrees from the altitude that I drew, and that's about it. Because I can't put 13 anywhere since that was cut into two pieces on that triangle. So my plan is this. If I can find this piece, which I'm going to call W, and then I could find this piece, which I'm going to call Z, I know that W plus Z is going to equal 13. And W is on this triangle on the left where I have enough information to do a cosine problem. I could say the cosine of that 44-degree angle is going to equal W over that hypotenuse of 6. So that means I'd have to multiply both sides by 6 to get W by itself. So when I take 6 times the cosine of 44, I get 4.316, which I'm going to round to 4.32. So I now know that this is 4.32. And since that's one of the pieces of 13, I can simply say that 4.32 plus the other piece of Z should have equaled 13. So if I just subtract that from the 13 minus the 4.32, I end up getting 8.68 for Z. So I'm going to go ahead and put those onto my triangle as well. Well, that is a number that I can put down here, 8.68, that will now help me find what X is. But I still don't have any angles in that triangle, so what I'm going to go back to is Pythagorean theorem. When I don't have angles, usually that's the only thing that I can do. So I'm going to do a Pythagorean theorem on this triangle on the left to find the height, and then use that height to do another Pythagorean theorem to find X. So on this triangle I should have that 4.32 squared plus the height squared should equal that hypotenuse of 6 squared. So I end up getting 4.32 squared is 18.6624 plus the height squared equals 36. So the height squared is going to equal 36 minus the 18.6624, which is 17.3376. And then I can square root and say that h is equal to 4.16. So now that I know h is 4.16, I can do another Pythagorean theorem over here where I can say 4.16 squared plus the 8.68 squared should finally equal that x squared. So when I do that, 4.16 squared is 17.3056 plus 8.68 squared, which is 75.3424. I add those two things together, and I get 92.648. And then I can square root that to find x is equal to approximately 9.63. So in this particular problem, CB is about 9.63. And if you look at all that work that I've done here for this problem, you could do that every time. But what I'm going to show you in the next video is how I could do this with just a formula, which we're going to call the law of cosines.